Hello and welcome to today's lesson. Today, scholars will apply triangle congruence theorems to prove triangles are congruent. So today we're going to learn about some congruence theorems. So theorems are just rules that we use in geometry. So, what is a congruence theorem? Because of the specific properties of a triangle, we can prove that a triangle is congruent with only half of the information. The information being the angle measurements and the side lengths. Okay, so first we're going to talk about the side angle side theorem. You'll notice on these I have sides that are the same. I'm coloring them in so you sort of see which sides I'm talking about. Notice the one hash mark, two hash mark to tell us that they're the same. And then I've got an angle that's the same. So let's look at how we can transform triangle UVW into triangle XYZ. So if I take this triangle and just sort of cut it out, I can take it and you see if I sort of move it over here, and you can see sort of how it is the same as this one. I can sort of turn it, and you can see how it is going to end up, if I reflect it over that line, it's going to end up being the same. So I can sort of turn this. Let me pull it down here. And you can see how these triangles would lay over top of each other if I reflected it. So those are the exact same triangles. So the side angle side theorem simply says, SAS, if two sides and the included angle, so notice the angle is always between the two sides, are congruent to the two sides and the included angle of another triangle, the two triangles are congruent. So this is how we prove it, is by the side angle side, SAS. So next look at our next theorem. This one is side, 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 or SSS. So again, we're talking about how we can transform these into the other. So once again, if I sort of cut these triangles out, you can see how if I just bring this over here, and then if I rotated it, I could end up overlaying the exact same triangles. Okay? So that's why they are the same. So triangles, three sides can only make one specific triangle. So let's look at the actual theorem. Again, side, side, side congruence. If the three sides of a triangle are congruent to the three sides of the other triangle, then the two triangles are congruent. It is that simple. So let's look at our next one. This one is angle, side, angle. So you'll notice here, I have an angle of 45 degrees, an angle of 45 degrees, an angle of 25 degrees, 25 degrees, and then I have one side that's in between them. So notice it's angle, side, angle. The side is in between the two angles. And it can prove that we can transform one into the other. Again, you can see how if we just sort of took this and reflected it over a line right here, you would end up looking at the same triangle. So just reflect it over that line. So the ASA theorem, angle side angle theorem, says if two angles of one triangle and the included side are congruent to the two angles and the included side of another triangle, then the two triangles are congruent. So ASA, angle, side, angle. So now let's look at angle, angle, side. In this case, I have two angles the same and one side that is not included that is the same. So angle, angle, side. Again, you can see I could sort of take this triangle and just sort of translate it over to put it on top of the other one. These are the exact same triangle. So the angle, angle, side theorem says if two angles and the non-included side of one triangle is congruent to two angles and the non-included side of the other triangle, then they are congruent. All these congruence theorems. Okay, this is one more theorem, and then we're going to get on to doing some practice. So this one only works with right triangles. So this is the hypotenuse leg theorem. Remember, the hypotenuse is the side of a right triangle that is directly across from the right angle. So this is the one with these two hash marks. Notice it's directly across from the right angle. And we can see that we have another side here that is the same. So one side of the hypotenuse is the same. We got the right angle. So it is really side angle, but it is special because we only actually have to know the hypotenuse and one leg. Okay? So this one only works for right triangles. Again, you can see if I sort of rotated this around and reflected it, we can end up with the same triangle. So a hypotenuse leg. So if the hypotenuse and one leg of a right triangle congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so we've gone through a whole bunch of theorems. Now let's look at how we use them. So how can I use the triangle theorems to evaluate these overlapping triangles? So we're trying to prove that triangle ACD, which is ACD, this triangle, is congruent to triangle BCE. So we're trying to prove that those two triangles are congruent. Okay, so what do I know about them? I know that they must both have this angle. So I know that angle C is included in both of them. I also know that this side and this side are the same. So I have a side. And then I also know that this angle and this angle are the same. So angle A is congruent to angle E. Which theorem would tell me that these are congruent triangles? I see I have two angles and I have a side. So this is going to be, and you'll notice that the angles are on either side of my side. So my angles are here, and the sides in between, here and here, the sides in between. So this is angle, side, angle. Would prove that these were the same. Okay, so go ahead and do your work in class and see me if you have any questions.